Hi guys, now we'll see today's LeetCode daily challenge, total waviness of numbers in range 2. So this question is similar to or same as yesterday's question, only here the constraints are bit vague, like they have gone till from 1 to 10 to the power 15. So if you want to see the brute force approach, you can watch the yesterday's video. I'll put the link in the description and comments. So now in this question, we are given two integers, num1 and num2. They represent an inclusive range from num1 to num2. Like here, two numbers are 120 and 130. They represent range of numbers from 120 to 130. Now the waviness of a number is defined as total count of its peaks and valleys. So for waviness, they have defined how many peaks and valleys are present in that number. So peak is defined as a digit is a peak if it is strictly greater than both of its immediate neighbors. Like here, if you will see 120, so 2 is peak because it is strictly greater than both of its neighbors. And here, if you will see like 130, so 3 is peak, it is strictly greater than both of its neighbors. Similarly, a digit is valley if it is strictly less than both of its immediate neighbors. Also, it is given that first and last digits of a number cannot be peak or value, and any number with fewer than 3 digits has a waviness of 0. Now we have to return the sum of waviness for all numbers in the range num1 to num2. So like for all the numbers in the range, for every number we have to calculate the waviness, and then for we have to return the sum of the waviness of for all the numbers. Like we'll see example to understand this approach in a better way. So here we are given num1 as 120, num2 as 130, and we want to find the sum of waviness of all the numbers from 120 to 130. So if we'll see like 122 is a peak in this, like because it is greater than 1, it is greater than 0. So for this number, the waviness is 1. Similarly, for 121, 2 is peak, waviness is 1. 130 also, 3 is at peak and waviness is 1. For all other numbers, if you will see, their waviness is 0. So total waviness is 1 plus 1 plus 1 equal to 3. Now we'll see approach how we can do this question. So we want like waviness from the range num2 to num1 or num1 to num2. So suppose we have a function solve of x. It gives sum of waviness from 1 to x. So in our case, we want from num1 to num2. So simply first we'll find the waviness from 1 to num2, then we'll subtract the waviness sum of waviness from 1 to num1 minus 1. And let's see some observations. Like if we have taken a particular number 4 5 6 7, so and we want to form all the numbers from like 0 to 4 5 6 7, then simply what we can do is we can start from the left position, that is 0th position, and here we can start putting digits like 0 1 2 3 up to 9. then then we can move to this place, then we can start putting similarly digits this place, so the numbers will be formed. But one thing we need to notice, like for the 0th position we can only put digits from 0 to 4, and if we have taken here digit as 3, then here we can put any digit from 0 to 9. So if we want to form all the numbers recursively, then one flag we would need to maintain. If it is true, that means we can put digits only from 0 to the digit which is present at this like position, and if the flag is false, then we can put any number from 0 to 9 at that position. So similar same thing I have written in case of 4 5 6 7. For 0th position we can fill only from 0 to 4, but suppose here we have filled 3, then later positions we can place any from 0 to 9. Also, since we want to calculate babiness, so minimum we need 3 digits to apply that condition and get. So what we'll do, if we are writing any recursive function, we'll maintain previous ka previous, so that like we can compare with our current element and apply those condition and calculate the babiness. Also, like if the previous digit is not present, like we are just starting, or earlier we have placed 000, so till now no valid number is formed, in that case we'll keep previous as well as previous ka previous as 10, which is a invalid digit, so that we can identify it previous does not exist, as our digits can be from 0 to 9. Then we will need to maintain whether till now any non-zero digit is present or not, because if any non-zero digit is present, we can place the zero digit and do our comparison, but till now all zero are only present, so that means our like previous and previous ka previous are not present, so that flag also will maintain. Now suppose this function gives the sum of waviness of all the numbers, like this is a recursive function. Its definition, it will give sum of waviness of all numbers from starting from this position till last, as well as count, like it will return a pair of sum as well as count of valid numbers from starting from this position till end, and like sum of the waviness from this position to end. And we can form one relation, like now solve of position plus 1 will give sum of the waviness from position plus 1 to end, as well as count of numbers from 1 to end. Now suppose the current number plus previous and previous ka previous satisfy any of the peak or valley condition, then in our final answer we can increment, like ideally we'll feel that we should increment by one only, but we are maintaining count of numbers also, because if we'll add this number before this position, then it will form the peak or value for all the numbers, so we'll increment our final answer by count. So like we'll see the code to understand this in a better way. So this is our solve function. Here we are maintaining the position from which we are starting. Then what is the previous digit which we have kept? If it is invalid, then 10 we'll keep. This is previous ka previous. Then this tied flag tells us if it is true, then we can keep our limit of digits from 0 to the digit that is present at this index. Otherwise we can put any digit from 0 to 9. Simply this is lead flag contains, like if it is true, then all zeros are only present, no valid number is formed till now. If it is false, then some valid number is formed till now. So if we have reached base cases, if we have reached that position equal to n, then we'll simply return that our count is 1, at least one number we have got, and sum is 0. You can understand this like there is one exit point. We are, if any person is crossing that exit point, we are counting. So if 10 persons will cross that exit, so we'll in that exit will give us count as 10. So now for this like position, we want to calculate what is the count of the numbers we'll get, and what is the sum of the like waviness we will get. So our limit, if we want to set like which digits we can try. So if this flag is true, that means we can only keep our digits from 0 to whatever the digit is present at this position. Otherwise we can try all the digits from 0 to 9. So limit we have, if the tight flag is true, then it will take only s of position minus 0. Otherwise it can take the, it will take the value 9. Now we'll try putting all the digits from 0 to limit, and then we'll see if is lead is true and the digit which we are trying to put is 0. That means new lead will also be 0, because the number till now is 0, and next also what we are trying to place is also 0, so it will be 0. Now for new previous, if new lead is 0 only, that means new, the current number which we are trying to put is invalid only, till now no proper number is formed, so we'll add, keep it 10. Otherwise if it is like false, that means some number we got, then we'll place the digit. Now we'll call this solve function from position plus 1 for previous will be new previous, and our previous ka previous will be this previous will become previous ka previous, and our flag, if earlier it was true and now also we have put the digit equal to limit, that means type is still true, otherwise it is false, and new lead will become whatever we have calculated we'll place. Now it will give count of all the numbers that we got from position plus 1 and that has crossed n, so that we will get in count, as well as sum of the waviness of all numbers from position plus 1 till n, whatever we got we'll store in sum. Now if we got some valid number, that is this new lead flag is false, and the previous is also a valid number, as well as previous ka previous is also a valid number, then we'll check whether the current triplet which we are maintaining is either satisfies the peak condition or valley condition, then we'll add this to our like sum which we were trying to calculate. And we are adding count because this triplet will form the waviness, will increment the waviness by 1 for all the numbers which we got from this, that's why we are adding count. After that, for this position the count will be equal to count only the number, the total numbers which have crossed n, and sum also, since we all the sum which we got from this position plus 1 to last, this sum also we need to add. Plus if this condition is true, then some extra, so some extra thing we have already added, so we'll add this sum also. After we have like this, all the iterations are done, we have tried everything, we'll return the count and sum. Now we want like for a given number we want to calculate waviness, like this contain calculates for a given position, this recursive function will give this function we want to calculate the waviness for a given number. So first we'll convert it to string so that we can apply iterations and all in a easy way. We'll calculate its size, then we'll call this solve function from 0th position, since there is no any previous digit present, so we'll keep it 10. Previous ka previous is also not present, so 10, and this tight flag will also be true, and then this is lead also will be true because till now only 0 is there we can get. So this function will give us count as well as the sum. We want the sum of waviness, so we'll do dot second and return that. Now in our final answer we want this total waviness between num1 and num2, so we'll find waviness up to num2 then minus waviness up to num1 minus 1. So now this is a recursive solution to, we'll see that there are many overlapping sub problems, so we can simply memorize it and then it will like be accepted. If you will run, try to submit this solution, it will give like, oh, time limit exceeded. Now we'll see the memoize solution. For that, it is simple. There are like four parameters. One, two, three, four, five parameters we are taking. So five-dimensional array we would need to store our answers. So here we can see the constraints num1 and num2 can go up to 10 to the power 15. So we'll need max 16 for the position. Then our previous and previous can go from 0 to 10. So we'll need max 11. And for these are flags, they'll need only 2. So first we'll do mem set and set all the values to -1. Now for every recursive call, first we'll check whether our DP array or the array which we are maintaining has that value. If they have that value, then why to compute? We'll just return from those array only. If it is not present, then we compute and we'll store also so that in future we can use them. Now, if we talk about time complexity, then in DP we can get by the total number of states into total number of iteration in each state. So here only the position can vary from for number. So this will be like we can get by log of n. All other are constant only, like previous will be 11, previous ka previous also can go only 11. Then bool also can have only two states. Then is lead also can have only two. So our time complexity will be we go of log n into 11 into 11 into 2 into 2.